Okay, so good morning all. Welcome back to DevOps sessions. First of all, happy Holi to everyone. Yeah. So, yeah, కొంచెం close చేసావా? Okay, so Jenkins, right? So did you all complete the task? Terraform with Jenkins? Okay. So where is my Jenkins server? I need to install and okay, let me install quickly. Sir, holiday or a holiday? Sir, getting error Terraform initialized in empty directory. That you check in Terraform only, right? What you Jenkins will do? You are in the wrong directory. Okay. So I need to install Jenkins first, right? So I need to install Jenkins first. Kubectl. Okay, so I'm going to install Jenkins by using Docker. Just understand only. Docker is pending in your end. Okay, it's a very easy process. Just what I'm going to say here. Docker pull. I'm taking Jenkins image directly. If you can go to Docker Hub, public, give Jenkins. This is deprecated one. Take this one. So this is the command Jenkins. You just take directly and run. For that, first Docker has to install in your EC2 instance. I think very first demo, right? I have given what is Docker and all. So I'm taking Jenkins server as an image. I don't think so. This I'm trying. The reason is this image not contains all dependencies. Understand? Like Jenkins server. Yeah. Docker images. So my Jenkins and Jenkins is available now. Okay. So I'm going to run as a container. Docker run -dt some data terminal -p 808 something, any pod name you can give, but the default container name, and you can give Jenkins and Jenkins. So container is running Docker ps. Yes, I'm not explaining any Docker. Okay, just I'm installing Jenkins only. You don't confuse here. Okay, 8089. See how quickly I have installed Jenkins by using Docker. Done. See, getting. Just I'm saying only there is a process. Everything is going with the Docker only. It's a microservices process, right? So that's what we can do it like this way. You can use Resu also. Anyway, let's go over actual process. This is for just for understanding only. Okay, see, exit cat. See, it may, okay. So I need to go in the Docker container inside. Okay, it is not in, just for your reference, I'm saying that. So my Docker container is running inside EC2 instance. I need to log in my container. I will take this password from there only. Understand? For that, I need to enter into the Docker exec -it. Before that, I need to check my container name. Yeah, this is the container name. Sorry, this is the container name. You can give, otherwise you can give ID also. Let me copy this one. Docker exec -it. You can give container name. Just give bin bash to log in your container. I'm in my container. Now you can give this path. Copy. See, this is the password. Understand? The processes and all. So inside EC2, my Docker is running. Inside Docker container is running. Container is not run on your EC2 OS. Once again, I told you very clearly, right? Yeah. There is a anyway. See, Docker, we are going to discuss. Okay, don't worry. Just come and guys. One question to everyone. Okay, one question to everyone. What is the difference between a virtualization VM and a Docker container? The very first day, I think I have explained, right? The size of the operating system is different. Okay. And one more thing, images is okay. You guys are on the track now. What is the difference between, okay, so one application running in your VM, one application running in your VM. When I say VM, the VM is running on one host machine or not? Virtualization machine is nothing but it is running on some host machine. So if I install some VM in my end, okay, by using VirtualBox something, if I create a one virtualization machine, so this VM will take hardware from where? Will take hardware from where? RAM and something else. Host mission. This is my laptop is my host mission, right? It's take hardware from my local laptop. In that case, if you're creating a cloud EC2 instance, that EC2 instance required hardware will get from where? AWS host mission. It is running on some host mission. We don't know where it is running. Is this clear? We don't know where it is exactly running, but they are giving access for VM. But actually, what we need to understand, AWS also will follow some virtualization. That is a Xen hypervisor. It's not Oracle VirtualBox. It's their own, okay, whatever the provider, Xen. If you create if you launch EC2 means the indirectly, so what is the meaning of here? If I select new mission, for example, if you give some name here what I need to select? Which VM is going to create that VM ISO image you need to attach here, right? But in what about AWS EC2 instance? The images are already ready. You just click. Is there any difference here and there? No, here the difference is our host machine is my laptop. I need to take care of everything. If my laptop is gone, crash, my VM also crash or not? Same thing, the backend AWS also will follow that instance in some host mission. That is a very big physical servers. Understand? VMs will not get from anywhere like sky and water. Okay. There is some running in the one physical mission, but they are not going to give access for that physical missions. They are giving VM access. Understand? The VM is running some AWS provider host mission. Okay. Then, okay, I will share my hardware from my local laptop here to run this VM. In that AWS EC2, will share a hardware from where? AWS physical host mission, where it is running my EC2 instance. Then what about OS, guys? What about operating system for this VM? Anyway, I have created one VM. If I switch on this VM, what is the operating system? So to run this, if I host any application on this VM, how this will work without OS? It will work? No. So OS, from where it will share? From where this OS will share? Give clear answer. From where this application, which OS it is going to work? On which OS this application will work? This, especially this VM I have created, right? If I host some application on this VM, we need a hardware, we need a operating system. Hardware is sharing from your host mission. What about operating system? Guest OS, huh? Same, but my laptop is Windows operating system, right? Depend upon image. Very good. Whatever image you are going to download and give this mission while creating time, if I give ISO Ubuntu image, this mission will work like a Ubuntu server. If I give something Red Hat image, it will work like a Red Hat server. The Red Hat commands will work. If I just CentOS image, it will work as a CentOS Linux. Some different distributions we have, right? Same thing in your AWS also. If you check Amazon Linux, if you click Ubuntu, it will work based on that image. It will work those commands, right? If image will change, your operating system will change or not. That's what you need to understand. So remember one point is very important. Your VM will not share OS from your host mission OS. This is very clear. If it will share, it will support only same operating system applications only. For example, this is Windows operating system. My laptop is. Okay. If I download my Linux operating ISO image, if I create a VM means, it will run that ISO image only. If it is not like that, if it will share from my Windows OS, definitely my Linux application will not work with Windows OS, right? So it will not like that. We can create multiple VMs, different operating system on my host machine, my laptop. It will run based on your ISO image. Is this clear, everyone? This understanding is very important. What about Docker? Docker will run on where? Docker will install on where? VM, that is AWS EC2 instance maybe. On that instance, Docker will come. Is this very clear now? So if you want to host applications, we should not host directly on host operating system. Create a Docker, install a Docker, create a containers. So inside application, we can host the container. Why I'm saying this example? Just now I have installed Jenkins image, right? If I give cat password, I'm unable to get the password. Why? It is not installed on your OS. It is not installed on your EC2. It is installed inside Docker. That's what, if I go inside Docker container, I'm able to get the password of my Jenkins. Understand the difference here? That is very important understanding here. So for example, Jenkins has a one sample application. My application is not running in my OS, right? It is going inside of my container, right? See, I have installed my Docker now. I haven't installed any Docker. If you can see here, I'm able to get my password if I'm inside of the container only. Jenkins password, cat. But if I come out, if I give same password, same command, there is no password, right? Jenkins is not installed on your OS. Which OS? EC2 OS. Understand? On EC2 OS, Docker is there. Inside Docker only applications are going to host. Clear? If I host same Jenkins in my host OS, here host means EC2. Again, EC2 is running a separate host, right? That's not taking care of us, right? I need to take care of EC2 instance only. On top of my EC2 instance, Docker is there. Whatever applications you can host inside Docker, not inside EC2 instance. Is this clear now? If you install an EC2 instance, the Jenkins will take maybe 5 GB, 6 GB, 7 GB again. To overcome that, using one EC2 instance, we are going to host multiple applications. For that, Docker is required. If you can see my Jenkins image here. Anyway, in Docker class, we'll go in depth. Don't worry. If you can see my Jenkins image size, okay, this is, yeah, 2.24 GB. The reason is they are giving like a all dependencies in the Jenkins in the image. Otherwise, very difficult to handle. Jenkins is take care of all the plugins, right? It has to take care of all the Terraform and all. So we should not compromise in that. Okay, one quick question. Maybe at this time we'll understand or not. Try to understand. If not, just leave it for today for this topic. Okay, guys. If I'm taking my Jenkins, right? This is what one image. Where it is running? To run this Jenkins image, what we need? Hardware is required. Operating system is required, right? Hardware is giving your EC2 instance. Operating system, who will give operating system to run this Jenkins? It is not running on my EC2 OS. Understand or not? It is running in, if I check my Docker images, if I go inside container, inside only Jenkins is running, not for directly on EC2 OS. Then how it is running? Without OS it is running? Then where is the OS here? It is running on which Linux? We don't know. Maybe it is running on Ubuntu. It is running on Red Hat. It is running on CentOS, whatever. But my Linux instance is what? Amazon Linux instance. But it has to support for all flavors. Why? It is not running on my EC2 OS. Clear no? If it is running on my EC2 OS, it should support only Amazon Linux. If it is Ubuntu related Jenkins, it will not support, right? Why you are using Amazon Linux EC2? That's what I'm saying, that your Docker will not share any operating system of your EC2. Whatever it is not related to your Docker. But only relation is Docker has to install that OS. That's it only. Whenever Docker is installed, whatever Docker is taking care of everything. Understand what I'm trying to say here? Then how this will run? We have image. Only which image it is? Jenkins image. Is this any OS image? Is this in OS image? No, it is in only Jenkins image. We are getting hardware from EC2 instance. Then what about operating system? So to run this Jenkins, you are taking image, right? This is running somewhere. Understand what I'm trying to say here? This is image is running somewhere. That is Docker Hub is providing that. They are providing directly image, ready-made image, right? This image contains OS also. That OS we are providing the backend. We don't know that where it is running. Understand what I'm trying to say here? No, sir. I need my OS. I'm not depend on their OS. In that case, what you need to do? Think. I need my OS, sir, not for their OS. I don't know which OS it is running. I need my Jenkins customized OS image. What you can do? See, I'm going to give a very good, Kiran Kumar. Okay, just understand. Okay. If I want to install Jenkins, what is your prerequisites? Leave it for Docker. Leave it for Docker. See, I have given one task. Install Jenkins. That's it all. What you need first? If it is a cloud means what you need? EC2 means what? operating system is coming or not? Taking operating system, taking hardware, and on top of that, connect your EC2 instance, and then connect your EC2 instance, and then install Jenkins. Here two actions. Action one is what? Taking operating system. I mean, while creating EC2 instance. Second one is what? Install Jenkins. Is this clear? But what is the difference here in the Docker? Just come out from the EC2 instance. Now in Docker, you are directly taking Jenkins. That is second one in the EC2 level. Installation Jenkins, you are taking as image. You are getting directly Jenkins. What about first one? I mean, first part in required OS, right? Means you are taking directly Jenkins, means the first already done, right? Understand what I'm trying to say? But where is that? That is taken care by Docker providers. Understand? No, sir. I'm not depends on the Docker providers. I need my creation. Means what you can do now? Create. Understand? Create instance, you can take it. That is instance process. But I need Docker process. How can we do it? Very good. What we can take? Take one image, OS image in the Docker, right? Like instance, you are taking one OS image, right? While creating time. Now here, while instance time, you click Ubuntu or Amazon line, something you are taking that. Same thing in Docker, we can take the image from the Docker only. Understand? In that image, what you need to do? Install Jenkins, same process, first process only, but image you are taking from the Docker Hub. Understand? That is, you are not depends on any direct ready-made Jenkins image. You are making everything from the scratch. For that, we need a first server. Which server? Ubuntu server, something. Take Ubuntu image. See, come here. This is very, very important understanding. If you know this logic, you can play with the Docker. That is a problem everyone face here. They are unable to understand this process only. Docker pull Ubuntu means what it will get here? Ubuntu OS will come. So compare with EC2 instance now. The same step compare with EC2 instance. Click Ubuntu AMI. First step is done. Second step, you need to select hardware, right? But here hardware will get from host mission. Understand? That is EC2 mission. There is no hardware dependencies if it whatever operating system it is. Hardware is same. That's what we are sharing hardware from the EC2 instance. Is this clear? So first step in EC2 instance, you are click AMI image. That is Ubuntu AMI image. In the Docker, step is to select Ubuntu image. Both are same. And after that, EC2 instance connect and install what? If required Jenkins, we can install Jenkins. Now here Docker pull Ubuntu, the size is only 28 MB. Understand? But in that size is 8 GB minimum will get. Whatever. But on top of that, if you going to install Jenkins, there is a big process, install Jenkins and all, you have to take care of that, right? Understand or not? But in that OS, Ubuntu, whatever selected that OS, many dependencies are there or not? Python install, not required. Java install, not required. Many Linux commands will run in that. Why? Many dependencies they have already installed. It's a default. It will work for all. If it is a Python, Node.js, NPM, everything it will support. Why? The provider will give that image, AMI image, keeping them in my mind, in their mind, it will work for default actions. That's what the image size is more. But here, what is my motto here? Jenkins installation. Then Python is required. No, that's what take a base image Ubuntu. You can prepare your image now. You not depends on the existing image what Docker is giving or what EC2 is giving. Understand? Here the size is what? 28 MB only, right? Now just install Jenkins on top of that. Maybe it will close to 500 MB, 600 MB. Understand? Now that image is run on your Ubuntu OS. No, sir. Can we do one more way? What is? I can take directly Jenkins image. So they are also follow same process, right? Docker also follow same process. They will run on this Jenkins some OS, but that it is not your job. You are taking directly ready-made image. No, sir. I want to do it by scratch. Means first you can take Ubuntu OS, on top of that install Jenkins and make it one custom image. That is called Docker file. Understand what is Docker file means? The instructions you have to give by from the scratch. Take the base image, what you need on that Jenkins, install Jenkins, make it one custom image. Run that image, in container will create. Inside container, what you install, it will be there like now. Understand? So, I mean, why we are doing this process means we are making all images required one. Whatever your application is running, taking like that only. We are not depends on default one. If you depend default one means 1,000 applications has to run means you have to deploy 1,000 default images. You are not going to use that images 100%. We are using only 5%. Remaining all default dependencies are there, right? Clear now? That's it. That is the difference between Docker and VM and physical server. Is this clear, everyone? Yeah, open source. So many people are saying that Docker, that whatever image you are taking, the Jenkins, right? Many people understand this process is this image is run in your EC2 OS. Many people thought like it is not correct, guys. It is not correct. Host OS, there is no dependencies. If it is like that, means there is no use of Docker. Your host mission supports, for example, Linux, Amazon Linux E2, EC2. Your application run on only Amazon EC2, Linux EC2, not for Ubuntu applications, not for Windows applications, not for Mac applications, right? But it is not like the Docker will support all distributions, all OSs. If you install on any OS, then why EC2 is required to install Docker something? We need one server, any server it is. Physical server, VM, or Ubuntu, Linux, any server. Just your motive is to run Docker only. If Docker is there, everything taken care by Docker daemon. Clear? Very good, Harshal. This is the requirement. We need a large size of EC2, only one. Understand? Only one. Not for each application, one EC2. Now clear now? Not only costing. If you want to provide high availability, how you can provide? Each server, you have to create one more standby servers. You can map it into auto scaling group. One application auto scaling is goes to create 3-4 servers, the same application. In this case, 100 applications, we need to create 100 auto scaling groups or not. And again, to give access, load balancer required or not. Multiple servers means we have to give a load balancer access, right? So each application, one load balancer again. So in this case, what I'm trying to say, try to understand here, the same process, if you can go on directly Linux OS instead of taking Docker family. So each application you need to run in one server. That is one EC2. The EC2 to provide high availability, again, we need to configure auto scaling and load balance. So those will create multiple servers. I mean, 100 applications, 100, not only 100 servers to provide high availability is goes to 300 servers. If it is a 300 servers, how difficult it is to manage your architecture. If one issue is there in any way, to find out the issue is very difficult, right? For that, that's what we are using container. Sir, container also, one container is fine? No, at least 6 containers, 7 containers for same application. Then who will create? Who will create required containers? Here auto scaling is created. Understand or not? Auto scaling is created. But in Docker, that's what Kubernetes is coming to the picture. Kubernetes is whenever Docker creating image, na, Docker job got done. That while creation of image. Now Kubernetes take that image and run a containers and take the control of the containers. If container, for example, it has to create 3 containers for this application. It is always maintain three containers. Always. Understand? Why? Kubernetes is a orchestration tool. So that image, whatever image you build from the Docker, right? From that image, we can create a containers by using Kubernetes. Means Kubernetes is taking care how many containers are required. If container will delete, immediately Kubernetes will create one more container in the place. Like our server is deleted means immediately one more server will come into the picture, right? If you configure auto scaling group, same process, it is a self-healing process Kubernetes is taking care. It is going to create immediately. If you want to give this access to public, we need a load balancer, right? Kubernetes is going to create a load balancer. If you write a YAML file, one YAML file, this is the application, means this is the image. You can take this image into your control, create a containers. How many copies are required? That is completely your wish. 3 or 4 you can mention into your YAML file, and that application you can give access to public. So in the same application YAML file, you have to define this is goes to work on load balancer. Is this clear? Let me show something. So for example, guys, this is my, for example, take some project all and everything here. Why I'm saying, if you apply your resumes, maybe it is helpful for you. They may ask, Docker something. At least you say something. Yes, I know Docker. If you can see here. For example, guys, if I take some project here in, okay, Swiggy, let's talk about what is this? Why Docker file is required? What is this? Some source code is there here. This source code, we need to build into Docker image. Why this is Docker project, Kubernetes project. We need a what? Finally, containers. Your application has to host in one container. From where containers will come? Images are, you need an image, right? So that image is custom image or default image? Custom image. So take source code, create image, where the source code is running. For example, Python. You need to install Python, right? Install Python, take base OS, copy your source code, install Python, package this image. Understand what I'm trying to say? For example, this is Python source code. Python code will run on Python only, right? For that, what you need to do? Create one EC2 instance, install Python, copy your source code, run. Same like laptop. My laptop, this is my server. My laptop is a server. Just try to understand here. This is a PyCharm environment to run Python code. Taking much time. I can take Python image also from the Docker, right? Instead of install again. See here. This code will run in my local laptop. This is what? Python code, for example. So Python code will run on your Windows OS. I don't know. For that, we need to install Python environment. Understand what I'm trying to say? My local laptop, by default, it is not run Python code. Why? There is no Python related dependencies not provided by manufacturer. What you need to do to run this Python code first, you need to install Python into your local laptop. Understand? Here server is your server is laptop. Your code is ready. To run this Python code, you need a Python environment. Otherwise, .py Python code we can store into .py like terraform.tf, right? To run your Terraform, you need what? Terraform in local. Otherwise, Terraform code is right, but there is no Terraform means Terraform command not found means there is no Terraform. For that, you need to install Terraform. Understand? For that, what I need to install here? Python to run. Now come to your EC2 instance level. Your laptop means what? EC2 instance. Okay, Python code is ready. You need to run means what? I need to install Python in my EC2 instance. All are clear now? Now come to this repository. This is my Python code, src in public something. To run this Python code, what I need? Python. So this is going to microservices process. So Python need not from Amazon providers, need from Docker providers. Understand? I'm going to run in container, right? Not directly on OS. If you are this project, you are going to host and directly EC2 instance means the dependencies you need to install your EC2 instance. Why? This project is going to run on your EC2 instance. But this project is to run in not in EC2 instance. Where? In Docker. Understand? Docker means container. Clear? If you can just compare with the example, just now I have installed Jenkins, right? Jenkins I have installed in the on top of the Docker, not on EC2 instance. Understand the difference here and there? That's what I'm unable to see cat command the password directly in the EC2 instance. Why? It is not installed on your EC2 instance. It is installed on top of the Docker. It is running as a container. So if you can go on my container, it will be there. Understand? So what I'm trying to say now, the same in the place of Jenkins, you just understand this is the source code, Python code. It has to run in where? Not on EC2 instance, right? It has to run on where? Docker container. Understand? Docker container means you have to take care of few things. You need a Docker OS. If it is run on Python, you need some OS image, right? Sir, we have already EC2 instance now. We are not taking EC2 instance. We are not installing an EC2 instance. We are using EC2 instance to install Docker only. On top of the Docker, I need to run this project. Okay, for that, what you need? Image is need, right? For that, image is need or not? The image contains what? The image contains, okay, you need to prepare some custom image. The custom image, final image contains what? Your code. Where your code is running, that is need to install. Is it clear or not? My Python application run on Python only, Python environment only. For that, what you need to install? Python. So for example, the same code, if you want to run in your EC2 instance, what you need to do? You need to install, you need to create a EC2 instance first. You need to copy entire source code into your EC2 instance by using git clone. We need to install Python and run Python command, Python space your file name, means it will run. But it is not, our intention is not to run on EC2 instance. Our intention is to run on Docker. So what you need to do? First, you need a, like EC2 instance, we need a Docker image, base image. That is Ubuntu or whatever it is. Next, what you need to do? Install Python. Next, what you need to do? Copy your source code from Git to your Docker. And it will run means container will create. To create a container, what you need? Image, right? Understand is not? Image. Whenever run image, container will create. The container inside what you need? Application, runtime, and all, right? So you, whatever, first you are taking base image, right? Like EC2 instance, one base image, that is also base image. From the base image, you are going to install Python. In the same base image, you are going to add your source code, copy source code from GitHub to here. Now run that Docker file. One image will create, final image. From the image, you are creating one more image. Understand? From the image is what? Base image only. Nothing is there. Like EC2 instance OS. Whenever you add that image, copy, Python, and all, creating one more image. This image contains all the stuff. Understand? Let's come now. Yeah, see here. Try to understand. This is very important understanding. For example, you have a Docker, you have a Python source, Python application. You have a Python application. You have to run this project. What you need first? If it is AWS EC2 means you are going to run this application in AWS EC2 means what is the first step? Create EC2. Create EC2 means what steps will get? Main steps. One OS plus hardware. Sir, we have a 7 step. Leave it. First, these are the very important steps. Okay. Tags and all just optional. Is this clear, everyone? And next, what you need to do? Step 2. Install. Very good. Install Python. What is the next step? Copy the source code into EC2, right? This code is there in GitHub. You can copy it, whatever options we have. Just clone it in the same repository. You can run it. Further, okay, Git will come automatically that in the EC2 instance, right? We need only to install Git. Anyway, very good point. Install Git also, right? But by default, given by AWS EC2 provider. Understand or not? This point is very important. That's what I have written here. Guess Docker introduction class this is. It is divided into Docker, okay? Just understand. I don't know, my mood is good for Docker today. Copy source code into EC2, right? Now, I need to run this application means just give one command, Python, like shell script, give sh or shell script name. It will run, right? Same Python, give your Python application name. I mean, your file name. For example, this is app means app.py. If you run means this application will run. Then you can give your public access, something, whatever it is, we can access your application. Is this clear now? It is on running on my directly EC2 instance. One application. One Python application. You are taking one EC2 instance. Is this clear? If it is 100 applications, definitely you have to take 100 EC2 instance. Is this clear now? So now first, okay, this is for only one instance. To get a high availability, how many instances need? You need one more EC2, right? Understand or not? You need one more EC2. You need one more EC2 instance, right? With the same dependencies or not? With the same dependencies. Clear? So 2 is fine. I don't know. Depends on the traffic. If the application is more popular, it has to create the same servers. 100 also. If it is a billion people are going to access. Understand or not? Now, how I can provide this multiple EC2 instances by using auto scaling, right? Manually, we should not create the instance. It's time taking process. We don't know, right? At the time, traffic is more automatically create instances. Already we discussed, right? In auto scaling group, CPU utilization is going to see if you can come here, task manager. This is my present CPU load in my laptop, right? It's the same thing, present load in my EC2 instance. Based on the traffic, I'm accessing multiple applications. It's vary. Same thing, my auto scaling group, I need to set the set point of CPU utilization. Whenever load increase, create a multiple instances. Is this clear? So that's what I'm writing auto scaling here. Okay, auto scaling. Okay. Now how to give access to the public this one? How to give access to public this servers? Load balancer. Why? Multiple servers is there. We have to balance the load. Okay. Balance the load and we'll get one ELB URL. We can map directly. Multiple instance means different IPs will be there. Multiple instance means different IPs will be there. How you can give different IPs to public access? If it is a 10 IPs, how you can give? That's what, to balance the 10 loads, 10 servers, give one URL, that is ELB is taking care, as we discussed. Clear? So what I need to do now? So ELB also required. ELB also required. Guys, please don't ask what is ELB at this time. Okay. This is clear. Any doubt on this? Any doubt? Who will create ELB? You have to create. Who will create auto scaling? You have to map it. So like this, one more application, second Python application. This is different one, right? What you need to do? Same create instance, create auto scaling, create load balancer. Same process and use different ELB and different auto scaling. Now you tell me guys, who is the responsible for this? Creation of auto scaling and ELB? Cloud or you? Hmm? Who is the responsibility to create auto scaling and load balancer? You have to take care, right? Cloud will not create. Understand or not? You have created or not TLBs in our lab? Auto scaling also we have tested or not? We have to create, right? Very good. Sharma and Harshal. Yeah, I'll come into that. Wait. Is this clear, everyone? Okay. Now the same process. So my client requirement is I don't have much money to create multiple instances for multiple applications. Can we do it by using one server? Yes, we can do it. That is using Docker and Kubernetes. That is process is microservice process. Same process we can implement with Docker. Tell me, guys. Now you have to say that. What is the requirement first? Your source code is ready, right? What is your requirement now? Source code. Yeah. Tell me source code is ready. Tell me, guys. First, we need EC2 instance to install Docker. That is primary step. Just leave it now. Yes, Docker is running on one server. Next, what you need to do? What you need to do? Docker is running. You need to deploy this application in Docker container to give access to public, like EC2. Okay. First, what I need to do? Create container, right? Container will create from where? When the containers will create? If you run a image. Understand? If you run a image. So what you need? Image. Let's understand. For example, if I take a base Ubuntu image, if I run that image, create a container. In that container, what will be there? Nothing is there. You run Ubuntu image, base image. You will get welcome to Ubuntu page only. Understand? But what you need? Python application, what you developed by developers. I need to run that image to get inside container, same application. Is this clear now? What you need? Image. That image contains your source code, required dependencies, and run that image container will get inside container, the source code and application will be there, right? Right or not? Yeah. So now we come here. What you need first? Tell me what I can do now. I need to prepare image, right? To run as a container. How to prepare image? I'm not asking in command and all. Just what I need. Just I'm saying that here. OS from the Docker hub. I need to pull OS. OS. Understand here two differences I'm going to show you. Two differences I'm going to show you. Okay, first difference, you tell me what I need first. Compare with this process. Same, compare with this process. What I need first. Tell me. OS, right? Base OS, right? Here, this OS is contains all dependencies. What AWS is providing that EC2 instance. I'm not going to deploy my application directly on EC2 instance. Understand the difference here? Here on top of C, okay, let's assume here, this is my architecture. This is what hardware. This is what operating system. On top of the operating system, Docker is going to run. I mean here, these applications on top of the applications means here containers. Understand? Containers. Okay. These containers, Python application, whatever. PY. For a high availability, one more PY container. Is this clear now? Where is my Docker? Here. Understand this architecture? For that, we need a OS. hardware. This is entire what, guys? Very good. EC2 instance. Clear, right? Yeah. This is EC2 instance or Azure VM or GCP VM or your laptop or VM provider on premise VM, whatever it is. We need OS to install Docker only. That right? This is EC2. So now you tell me, guys, your source code is there in Git, right? So what you need first to start the project in the Docker, what you need EC2 instance. Yes, you have created one EC2 instance to install Docker. You have installed the Docker. Docker is running fine. Now, first step is what? What you need? Compare with EC2 instance here. Base OS. Take base OS. If this application want to run in Ubuntu server, you can take Ubuntu EC2. This application want to run in Ubuntu server, but it is not EC2 instance. It is in Docker means you can take Ubuntu Docker image only. Clear? Instead of taking Ubuntu AMI from the EC2 instance, why this code is not running on your EC2 instance? It's running on Docker. Clear? For that, what you need? Base OS, Docker. Next step is what, guys? Taking base OS means taking one EC2 instance AMI means created one EC2 instance. Taking base OS means you can understand one EC2 is created in the backend. You just assume it. Here one EC2 is created. Later what you did? After creation of EC2 instance, what you did? Install Python, install Git, required dependencies you have installed and copy the source code and run it, right? But here I'm taking only base OS. Here I'm taking OS plus hardware. But here what about hardware? Very good. Share from host OS. This EC2 instance. Is this clear now? Okay. Next, what you need? Install. What about Git? Here Git is by default is coming. It's a large size of Linux AMI. They are giving all dependencies, Python, Java, whatever it is. It's a basic dependency. That's what's the size of the OS is the more. Understand? But here I'm taking just base OS. Base OS Ubuntu or base OS Linux. Okay. But in this Linux OS, nothing is there, just a base image. But in this AMI OS contains so many dependencies, right? But not required those dependencies to run this my code. Whatever dependencies required your code, you are install that only. I not require Java. Why I need to pay for Java here? My application is Python, right? Okay. Anyway, base OS Linux pull from where? Docker Hub. Is this clear? First step. Your base OS is ready. Hardware will take from the EC2 instance. So EC2, like EC2 instance, we are done. Like EC2 instance. Now what I need to do now? Install Git first. Why Git is base image? Nothing is there. You have to install everything from the scratch. Next. Very good. Install Python. Next. Copy source code. Next. Done everything. To run your source code, Python is there. To get your source code, Git is there. To run all these, first OS is there. That is Ubuntu OS. To take the hardware, our EC2 instance also ready. All are ready, right? What you can do this? I can create a image. I can create a now image. Now you tell me, guys, this image contains what? I'm writing here. OS, which OS it is? Ubuntu OS. I'm taking Ubuntu base image. Now plus Python, very good. Python source code, right? Python source code. And to run your Python source code, one OS is there. To provide hardware to run, take from EC2. Clear? Host EC2. Where Docker is installed that EC2. Clear now? So now I want container to run your application. So you can create a container now. From where we can create container? Image. Very good. Okay. Where containers will run? Your host EC2 instance. Is this clear? So guys, how this image will create? First of all, we are taking a base image. This base image from Docker Hub. Let me write here. Docker Hub. From Docker Hub only, we take a Ubuntu base image, right? By using pull option. After that, installation git and install Python something. We're creating image, right? How to create image? This is called Docker file. We're going to add, these are the multiple instructions, right? Multiple instructions are there are right. Yes, these are the multiple instructions. Okay. So how to create image from the Docker file? We have to use this command. Docker build -t means image tag name. What image is required? Image name. So I can give Docker build -t Python and run this file. Give the file name. If you run this command means one image will create. Okay, one image will create. That image is what? Custom image. This one. This image contains what? Application and source code. If you run this image, container will create. To run your container, OS is there or not? Ubuntu OS you are taking from scratch, right? Yeah. Now tell me one thing is, like that if I need a multiple containers, I mean scaling. Two containers, right? First we need to increase the containers count, I need a scaling. To give access, I need a ELB. Understand? Load balancer. So this is taken care by Kubernetes. Kubernetes taking care, scaling of your containers, and also access, right? Also give access to public. So here we need to understand. Kubernetes taking care scaling of your containers and also give access to public. So now come to this project. What is a Docker file here? Why Docker file is required? Observe here. Why Docker file is required here? To create image. Create image from where? Source code. This is the code. And in the Docker file, okay, from Node.js. I mean, this is Node.js application. For that to run Node is required, right? From Node 16. Okay. And work directory. Create one directory, Docker file instruction, create some app directory. Copy your source code by using copy instruction. Run npm install. This is dependencies. I mean, Python install, run Python install. Run command is to install something. These are some commands in Docker file. 7 commands are there we can discuss. And expose this port, this application. Okay. And build this Docker file means one image will create. That image contains what? npm copy app node. Understand? Everyone? Now, okay, one image will create, right? One image will create. From the image, what we need? Container. Docker will run the image. Container will create or not? That container contains what? What image you prepared? Source code plus dependencies, right? But here that containers high availability and orchestrations, scaling, access, public, and all taken care by Kubernetes. So there is a Docker Swarm project also, but it is not like a Kubernetes. Applications, multi-applications, multiple scalings, it will not support. That's what we are depends on Kubernetes. So here that what the important point we need to understand, we are going to use Docker in real time to just build an image. That's it only. I mean, that image will come from where? Docker file. The Docker file contains what? Your source code to run the source code dependencies. Is this clear? Whenever build the Docker, image will create. Understand or not? Whenever build the Docker, one image will create. That image contains source code and dependencies and all. But we are not going to run that image by using Docker. We are going to run that image by using Kubernetes. Is this clear? So if I run the image by using, if I run the image by using Kubernetes, we are calling pods, not containers. Is this clear now? I mean, the backend container only there. Whenever image will run by using Kubernetes, we should not call like a container. We should call like a pods. This is Kubernetes under. That's what. I mean, what we can understand, if the image is ready, if you run by using Kubernetes, it is run like a same Docker container. Container contains application, right? But here, one more layer will add. That layer is pod layer on top of your container. If you run image by using Docker run command, it will create only container, not pod. It is not a Kubernetes family, Docker family. If you run image by using Kubernetes, it will create a pod. The difference is, if you run Docker run from the image, container will create container inside application is there. If the same image will run by using Kubernetes, same container will create, same application will be there. But additionally, one layer will be added. That layer is called pod. Understand what I'm trying to say? So in the Docker point of view, we can say containers. In the Kubernetes point of view, we can say a pods. If you run image by using Docker, we can call it as a containers. If you run image by using Kubernetes, we can call like a pods. But both are same. But Kubernetes will not take control containers. Why? There is no any Kubernetes family layer on top of that. Whenever Kubernetes run the image, one layer will be added pod. That layer will link with your Kubernetes family. Okay, this is my pod. Container will not understand Kubernetes. Why? There is no layer on Kubernetes layer on top of that. Whenever Kubernetes layer will come, when the Kubernetes layer will come, if you run the image by using Kubernetes only. Understand? So in this case, we are using Docker to build only image. Why? If you run a Docker container by using Docker run, the high availability scaling and all has to take care by Docker only. But if you run the same image by using Kubernetes, the high availability of the containers and taking care by Kubernetes. Understand now? So Kubernetes source is what? Docker. What is that source exactly? Image. Clear? To build a image, Docker required. To run a image, Kubernetes is required. Why Kubernetes? To orchestrate the container. If you can come here in the EC2 instance, if you want to give high availability access for the EC2 instance, you have to create auto scaling. You have to create load balancer, right? But I'm saying Kubernetes is taking care of everything. Sir, how Kubernetes is taking care of everything? That we can discuss now. There is one more file, right? What is this file is? To build an image. Clear now? To build an image, Docker file is required. To run an image, Kubernetes is required. This is the Kubernetes directory. So just go inside. Go to deployment.yaml. We are going to deploy your image into one container. But that container is called pod. Why? We are using Kubernetes to run your image. So this is deployment.yaml file. In the deployment.yaml file, what is your source? Docker image. Hey, Kubernetes, run the image. Okay, Kubernetes will run backend support by using YAML files only. Like Docker will run by using Docker files only. Like Kubernetes also, we have a file that is a YAML file. So what we need to give the Kubernetes YAML file? Docker source image, right? See, I have given even image. This is the image Kubernetes you can run. Before that, what you need to do? You have to build a Docker file to generate an image, right? This is the image path. Hey, Kubernetes, run the pod. Where is the image? This is the image. Is this clear? Now, how many replicas required? How many containers is required? See here I have given 2 replicas, 3 replicas, 4 replicas. Just change your number, Kubernetes will create everything. Understand? Now, okay, as I said, Kubernetes is creating a multiple containers from the Docker image source. That Docker image contains application and all. This how many containers are required? You can mention in your Kubernetes YAML file. Kubernetes will create the number of copies. Then one more challenge, how to give access to public. Here we are going to create load balance to give access for if you are running your application in EC2 instance directly. But I need load balancer right here to give access. Load balancer is service or server? It's a service, right? I told you, right? Load balancer is a service. So here Kubernetes also, if you want to give this pod access to public, I need to create a service. That service means load balancer I'm going to create. Understand? There we can go and check 1 step, 2nd step, 3rd step, and load balancer. We can create and configure your target groups. Here target group is means what? Containers. So for that, I'm going to create a service. Hey, Kubernetes, after deploy this application from the Docker Hub image, the Docker Hub image contains application and dependencies. So 2 copies you are going to create, right? Please give access to outside for these 2 copies. For that, you need some service, right? The service is called load balancer. Come here. See, I mean the respective application, you are creating a load balancer. Just give this type equal to load balancer. That's it. Kubernetes is going to create a load balancer, the backend. If it is a Amazon Kubernetes, Amazon load balancer will create. If it is a Azure Kubernetes, Azure load balancer will create. Understand what I'm trying to say? Cloud Manager Kubernetes means Cloud Manager load balancer is going to create the backend. This is only one application. One application, one Docker file, one YAML file, one service file. Clear now? This is very high level introduction of Kubernetes. So whenever run a Kubernetes by using Docker image means we have to say how many copies. Clear? We have to say what service they need to enable. Same actions we have implemented in EC2 instance also, but those are we implemented by using manual process. Here 100 applications there means I need to write 100 deployments. The deployments all are same. Just change the image name. Understand? Change the image path. All service files are same. For that image, how this service is linked with that only, sir, how can I say that service is work for only this deployment? This is called labels. In my service, I'm saying you just apply this service for this only this deployment.yaml. How I can say here? By using these labels. Sorry, by using these labels. These labels already have given my deployment.yaml. So this service will link with that deployment.yaml. If you create a 50 deployment.yaml, deployments are same, right? What I need to change here? What I need to change here? Here, what I need to change? This image only. Second application, second image will come, right? Second dependencies, different dependencies. So one more deployment.yaml. For that, one more service. For that, I need to change the labels here. Second application labels, second application labels, second service. So applications are increased, deployment files are going to increase, service YAML files are going to increase. The backend managing, not you, managing your Kubernetes. You need to manage YAML files only. Instead of manage physically, go and check your load balance and auto scalings. You can verify here only, just commands, 2-3 commands. We can, everything is taken care by Kubernetes. Is this clear, everyone? No? Now, just 2 minutes, focus here. Here, can I do one more thing instead of do that? See, I'm taking which image? Can I take directly from Python? Understand what I'm trying to say here? Instead of taking OS and install Python, take directly Python image. Copy your source code. Python image means Python will support, right? Understand? From Python, copy source code. Run it. Run the image. Run the Docker file. But this image will run on which OS? Maybe it is running on some Ubuntu image. It is running on Ubuntu or CentOS, whatever it is image. But you are not taking this image. Already Docker providers ready-madely giving this Python image. Means they are running in some OS, right, backend. But this is not your responsibility. You are taking directly image from Python. But it has run some OS and backend. But they are giving directly Python. If you not depends on this backend, you can take a Docker Hub based Ubuntu, you can make it your image. This is the difference. Understand? This is the Docker and Kubernetes very high level. Clear? Tell me, guys. Who will manage the later? Who will manage the later means your Kubernetes YAMLs will be managed. The YAML files you have to take care. Instead of go and check physically, can't you take handle YAML files? Sit. Why, Sharma? Versions are here. Why are going that level? Version update means what? Docker file will update. Docker file will update means what? Image will update. Image will update will means Kubernetes pods will update. That's it only. Understand? 2 commands. Docker build. First command Docker build. Second command create a pod. That's it only. 2 commands. What are updates is taking care? Understand? Update your Docker file. Give the different image. Very good point. Arun Kumar is catched that. Can't we manage without giving the replica? It should increase or decrease depends on the load. Very good point. Okay, I'm waiting for this question, but Arun is asked that question. See, if you observe that my deployment.yaml, my replicas is hard coded, right? 2 or 3 or 4 or 5 are right. If I give 4, 5 means it will not support for 6th one, right? 6th container. If the load is there or not, always maintain 6th containers. You can compare with this one, auto scaling desired point, desired set point. What is that? Auto scaling desired set point means what? Whenever launch your auto scaling, whatever set point you have given desire, it will maintain directly. Then it will come to minimum maximum set point. Or can that is dynamic approach. Can we make it static? Means scheduled part, schedule based nodes. EC2 instance. Particular time will come, it will create a 3 nodes. Particular time will come, delete the 3 nodes. That is static, not dynamic. But we make it dynamic, right? We need to write one more YAML file. That is horizontal pod auto scaling that YAML file. We can give a target this deployment. Horizontal pod auto scaling is taking care by everything. Let me show something for that. See here, horizontal auto scaling. See, actually what we need, deployment.yaml, service.yaml only. But one more YAML is that, just leave it for this. One more YAML is what? Horizontal pod auto scaling. Make it dynamic. Whatever you have hard coded this value replicas, I'm taking into the dynamic way, not in static way. What I'm going to say here, this is my deployment file already there in my file directory. This deployment file, minimum replica already given 1, maximum replica 10. It is going to take care of your deployment file. Whenever load is coming more, it will trigger to your deployment.yaml. Increase the load up to 10. Where is the dependency? CPU dependency. Same auto scaling, you have given instruction manually, right? Same instructions I'm giving by using YAML file. Understand? Is there any other things are there here? No. This is already we discussed one only in auto scaling. Don't focus on YAML file. Understand the subject here. Sir, why 2 dots? Sir, why mean? Just we can take care of that. But what is our understanding here? What is the dynamic set point here? CPU utilization. What is the set point of CPU utilization here? I have given only one. One CPU utilization comes means automatically how many replicas has to create? Max 10. Minimum 1. Same like auto scaling, like calculating average load. But which deployment to increase 10? Which deployment to decrease 1? This deployment. Understand? This is just horizontal auto scaling is a call to someone. Hey, which deployment I need to manage for this CPU utilization? This deployment. This is the deployment, make it replicate 1, right? Taking horizontal auto scaling YAML help, it will manage this YAML under control of HPA, horizontal auto scaling. That's what in the horizontal auto scaling target I have mentioned, my kind deployment. Now it has to increase as per the CPU utilization. Horizontal auto scaling sends to this deployment.yaml. Load is there. Can you increase the 2, 3, 4? Understand? Yeah. How about the monitoring? That's what we are going to implement here, Grafana, to monitor. In HPA, all replicas are created same pod. Question is wrong, first of all. Okay. Replica means only pod, right? Understand? One pod, one replica, 2 replicas, 2 pods. You can ask this question in one more way. Can I create, can we create same application in all pods? Replicas? Yes, same application only will come. How same application will come in AWS EC2 auto scaling group? How we can say that? We are creating AMI image, right? Launch template, right? And configure auto scaling. Here, no need to do anything. It's taking care by Kubernetes. Is this clear, Enter? What is a Docker? What is Kubernetes? Why we need to do and everything? This is very high level. Next 20 sessions covered today. Yes, you are very good. So don't check it in any YouTube's, guys. They are definitely confuse you. Many people are saying, yesterday, I think few days back, I have seen one video. That guy is saying, many confusions. This video is going to clear your doubts. What is that? I went through that video. That guy is saying that our all images, applications, From where operating system is coming? Many people are confusing that, right? This is the solution. This guy is saying that EC2 instance will give the operating system support for that applications. They are saying like that. Okay, don't follow any YouTubes first of all. They are giving some thumbnails, but wrong inside content. Okay, attract the viewers, whatever it is. Sir, one doubt. No YouTube guru. Sir, you going like Sir, one doubt regarding Jenkins. It was initialized in pipeline directory rather than pipeline Terraform CI/CD directory. The main CI directory show how Jenkins run the Terraform CI directory. So wait to don't initialize them. So guys, you have to give your Jenkins correct path where your Terraform is there. Clear or not? So that we can understand. If you are giving a wrong path, your Jenkins is unable to create your same path. See, the same step if you run Terraform init, no changes will come when if you are not in correct directory. Same Jenkins also doing. Understand it. Sir, you are going like a one. See, if you are unable to catch means 17 classes, you are saying that in one class I'm explaining means try to understand high availability concept. I mean, very high level. Don't think how to write Docker file in this class. Don't think how to write a Docker Kubernetes YAMLs in that. Okay. What you need to understand? One Docker file is required to build a image. That is a 1 point. To run a containers, one Kubernetes YAML is required. This is the 2 points you need to understand. If you are unable to understand, means definitely I can say one thing: you are not attended my AWS classes. You are not following AWS classes. You say one thing is, what are the dependency for this Kubernetes now? AWS auto scaling concept, AWS load balance concept. If you don't know those concepts, don't ask any question in Kubernetes from me. This is my sincere request to you. I have spent 30 days time with you. Unnecessarily, I feel like that. If you are asking that question, how auto scaling will work, I have shared the blogs also. Okay. That's what many people think Kubernetes is very difficult. The reason is directly they started DevOps classes without AWS. Understand? You guys are practice well Terraform. Why? We have already discussed first AWS. If without AWS, just assume it. Is it possible to learn Terraform? I don't know. Many trainers cover AWS last after Terraform. Same thing. Without auto scaling load balancer, Kubernetes will not understand even one person. If you know that knowledge, this is very, very easy topic. Kubernetes. Understand? Yeah. Yeah, yeah. So whatever I have explained this class, we are going to practice at least 25 days. Docker and Kubernetes. Okay. If you are able to understand this class, that one I have explained under Docker and Kubernetes, you are the gem. If you're not understand also, no problem. Wait for that time. Clear? Okay, guys. We'll discuss tomorrow. Same question. See, that's the problem here. Why Docker is required OS? Docker is all running on top of ES2 OS. So you are saying again, Docker container sharing EC2 OS, right? Again, you are in the wrong direction. That's what I'm keep on saying. What Docker is running on EC2 OS, not Docker container. To install Docker, we need a OS. To run a Docker container, not EC2 OS. The same point I told you many times. This is the confusion. Nagarjuna, understand it. EC2 is required to host a Docker, not container. To run Docker commands, we need a Docker, right? That's what we have installed Docker and EC2 instance. But whatever applications running in Docker container, those containers run on whatever OS you are taking that OS. Thursday to Sunday holiday, na sir. Very good, Sharma. You run on your local means not required EC2 instance, right? My laptop. That's it. See, I need Docker to run, create images to run containers. I need some platform. take EC2 or local laptop. That's it. Okay, this understanding is very important, guys, to understand coming classes. Okay, I supposed to cover Jenkins, path, something else, but we are diverted into Docker and Kubernetes. Anyway, tomorrow I'm going to discuss Jenkins again. Some topics are left, triggers and all. Okay, thank you so much. Bye.